I'm going to recover everything, and I recommend you do too, just so that you have everything in front of you. For the proof that we had, I think I gave you a homework problem where you had to do a proof of DeMorgans for intersections, right? So this should help you with that. So I want to tee you up for success on it. The first step as we went through this is to make some examples. So, you know, I'm going to actually blow past that. I think I drew a Venn diagram as my example, but I want to see, like, get a feel for what's going on. Second step is to write your first statement, if-then statement. So you're supposed to show, just to remind you, A union B, and yours is very similar, is equal to A complement intersect B complement. How do you show two sets are equal? Right, so two proofs. I look at everything in terms of labor. How much labor is this going to take? Two proofs. So the first proof I have to show is this direction. Second proof is this direction. So I'm going to start with the first one. I should see scratch work. I want to see your scratch work. Because when you come in for help, or if you ask me something, I need to, like, pull things from what you did. I don't want to give you, like, it's not going to help you to see me run proofs. That was the issue that I was having in grad school. He was writing proofs. If I went to him for help, he would write more proofs. But when I got back to my dorm room, I couldn't do any of them myself. Like, it doesn't help to watch someone else do it, because the idea of a proof is to make it clear as a bell so no one else sees your sweat and tears. So he's making it clear as a bell. I'd sit there and go, I see that. Okay. Then I go back to my dorm room to do a different problem. I couldn't do it because I didn't understand what was in the background. So I need to see your scratch work. So that when I help you, and I intend to help you, so you don't, if you're struggling with something, get help. Some of you are used to this. It's great, actually. I always tell my kids, you know, you don't like your teacher, you're struggling with something, go on YouTube. You'll find Saul Kahn will do a great job explaining this to you. So you're used to that. And but I think in the world of proofs, there's so many different ways to explain things. It's overwhelming to see things. So everything is right in class. And the least amount of work you're going to have to do is just, if you get stuck, text me the question. Just text me. I'm stuck right here. Text it at the moment. If I'm by my phone, I'll answer you at the moment, and you just can keep going. It's going to cut back your time. And it's going to help you understand things too, because trying to sift through all that information is tough. All right, so scratch work. First step is to write down the first if-then statement. This is step 2 on proof guide. So I guess I'd like to write this detail. A subset, A union B subset of A complement intersect B complement means, by definition of subset, that's where that's coming from, that if X belongs to this side, then X belongs to that side. You got to cite all your stuff, all the definitions, where it comes from. That's where that comes from. So that's your first draft of the if-then statement. Next step is to expand this. So I'll pause there for a second. Let me do this, actually. See how adept I am in class doing this. No, not adept at all. Yeah, that's nothing looks different, right? This is what it feels like when I write stuff on the board. Yeah. Where's that undo button? Let's do this. I'll delete it later. Let me go back to here so you can get all your information. Everybody got that? All right, so next step. I think you should understand slide 2. If you come in for help, I'm just going to show you slide 2. So we're actually on step 4 right now. Step 3 was to, oh, actually step 3. So let's start. You're extracting the no. So it's the language between the word if and the word then. And so that was X belongs to A union B complement. Next step is to expand the no. I pointed out a few times that the proof wiki was actually designed by students over the years. And for me, I just go to the show right away. And a few of them said, no, I need to like finish my no completely before I go to the next thing. So this order was designed by students. So I every time I try to change something, I've been told, don't, leave it that way. So this seems to be how a beginner proofwriter thinks. Okay, expand no is the next step. So you just basically, in this class, most of the time, you're going to be writing things down by definition. So you usually write, this means from your definition of complement. So you keep like, it's like you got one of those, have you seen those towels that are tiny and shrunk and then you pour water on it and it blows up? My kids used to love those. I loved them. I thought they were cool. So that's what you're doing. You're blowing up your no. You're pouring water on it, figuring out, like blowing it out. And the next step is to expand further. You want to expand this thing as much as you can. Well, I know what A union B means. So what I have is that that Y doesn't belong to that set. So I'm just going to expand it one more time. And I use Z's here so I don't keep using the same letter. I just did. That's what that means. And I didn't do this in my notes. Like, I think I do certain things. And then I look at them again with a cadet, I say, oh, I didn't do that. So I usually, like, as I'm doing all these notes, I box off something that I like as expanded as far as it can be. So it looks like it's expanded as far as it can be. So I'm going to like put a little thing around here so I can go back to it. So I see it in my notes. Like all the other stuff before that was not important. These are my nuggets. These are my puzzle pieces I need to use to write my proof. All right, next step. Oh, these are dummy letters. My topology class is actually making me more honest about this. So if I keep using X over and over and over again to stand in for the dummy letter, it starts to get confusing, right? I got an X that belongs to this set, and then I've got an X inside the set right? It's not the same X. And so I'm trying to be a little bit better about not using the same letter. It's variable abuse. Josh? All right. All right, next step. Extract the show. So you're going to do the same thing. Your job is to start from the no and end up at the show. So one of the common things that you see beginning proofwriters do is using their show to do something. They'll like assume their show. And you might think that's really dumb because you're supposed to end up at your show. But these structured steps force you to not do that. Like you start with the no and you end up at the show. So what are we supposed to end up at? Well, let's show is words after then. So the words after then say show X belongs to A intersect B complement. That's what the words after the show mean or say. And then you go on and do the same thing you just did with the no again. So step 6 is to expand that show. And I can expand further because there's a definition of complement. I still abused variables. And I can do the same thing for B complement. But that doesn't help me. I need something that my hands can get onto, right? So I want to expand it as much as I, oh, you mean right at the beginning to say X? Yeah, I'm going to use that. I'm just expanding. What does this that mean? It's instead of Y that it, so I'm expanding that out. That's the definition of being in the complement. Right. So you can conclude X does not belong to Y, but this is just expansion of the definition. So I'm like a robot just going through the definitions and expanding it out. And that's where I'm supposed to end up. That's what I'm supposed to show. So this part here is my last sentence. Therefore, X does not belong to A complement and X does not belong to B complement. Your last sentence should have something like this. So now you have everything. You have everything in front of you. You've expanded everything. You have boxes around the stuff that you're going to use. You assemble your proof. So it's your scratch work proof. So this is like the meat of the proof. I used to, when I taught this earlier in my career, students, I didn't do this structure and they'd say, well, I just want to get to writing the proof. I want to just do that part. Well, you kind of have to do that preamble part so you can pull out your nuggets and then put it together. And that's when we realized in that first class that you have to slow down and put things into order. So it's a lot of front end work before you write everything up. But now I'm just going to assemble everything I have.
Number 9.
Yes.
So
Yes, so now that we're going to show you the last thing is to show you the version that Professor Kurtz used to show me when I used to go ask him for help. So I don't see any of the work. I just see here's what it looks like as a clean proof. Right. So now you're just going to shape everything together. Once you have that, you're going to write out the stuff. So it doesn't have all my like junk at the beginning. Let X be on, like I don't put all that here because I'm just assembling all the stuff together from front end to back end. So in front of me, sometimes what I used to do is put my paper, I like loose paper because I can put it in front of me and see everything. So I know where I'm supposed to end up. I'm supposed to end up with something like X is not in A, X is not in B. That's where I'm supposed to end up. So that should be in front of you if you have your notes. So I'm looking at that saying, how can I get there? It's harder to show something's not in a set. So that's why I'm going to use the opposite. Okay, so here's how I did this, going over this. So I claim this is true. What did I write here? Yeah. Okay. So yeah, I'm not seeing this thing, and I'm seeing it here. There. So this is my claim. It doesn't belong in there. It's hard to show something doesn't belong in a set. It's easier to show something does belong in a set. And so that's what triggers me to assume the opposite and come up with a flawed logic. So I'm going to assume the opposite, assume on the contrary that X does belong in A. Well, if X belongs to A, then it belongs to A or B by default. So it belongs to the union. But I just wrote up here for my hypothesis that it isn't in the union. So I just starred that, so I can refer back to that. X can't belong to the union, so my assumption is wrong, and X does not belong to A.
Instead of writing like the claim and the conclusion, you not expand it further to be like X is not one to A or X is not one to B. Like this, the like equation. Like write out, like instead of using Z, just take out the substitute variable.
Yeah, I am using that, right? So you could write it out like that if you want to.
Okay, but
Yeah, that's what Zoe was asking. What does it need to be a member of this set? But this is a little harder to work with. I mean, the step before it was, before expansion was X does not belong to A or B, right? So I'm really keeping all that in front of me.
Sure.
So all your notes are in front of you. So
Yeah.
right?
I was just wondering, writing it in like the notation set versus writing it word using the contrary. There's issues.
Yeah, if you look at the checklist on there, if you just give me like a bunch of mathematical freight trains of formulas, that's not a proof. There's gotta be language around it explaining what's going on. And you're gonna see my clean version that's gonna have it with less words. This is just me assembling the proof. Yeah. But yeah, I love when math undergrads say, I got into math because I hate writing. That seems to be all I do. I either write grants or I write papers or I write proofs. It's a lot of writing. Yes, it is. Again, it's like that end point when you write your clean proof, the person should not see your blood, sweat, and tears. So you kind of lull them into thinking, hey, this was all so easy. They should look at your proof and go, this was easy. Okay, so claim 2 is the same. I'm not going to do that again because it's identical to the first one. Most people who start writing proofs err on the side of writing less than they should. There was only one time that I remember someone writing too much, and that he was a lawyer and he decided to get a math grad degree, and he gave me like 12 pages for a 1-paragraph proof. And I can't accept this. Like, this is, and he said, but it's not wrong. And I said, yes, it is. It's a badly written proof. Like, it's badly done. I need to see this clear, and it's unclear. So if you're writing like that, the lawyer's the only one I ever had that wrote too much. Lawyers always want to do math. I'm not quite sure why. Ramal was a lawyer. There's a lawyer named Beal from Texas who proposed something called Beal's conjecture. Like, don't they have enough to do than to bother us? But yes, that's the only time I remember someone writing too much. Okay, this argument is the same. So I'm not going to do that again. That would be too much. But for your sake, if you get something knocked off, like on your thing, say, hey, you wrote too much, you could have done this. I'm not going to count that off. I'm just going to say, hey, do you understand that you could have just said this is identical to that previous step? So err on the side of writing more than not less. Right, so far so good. Everybody understands it? This completes it. Or expansion 2, right? That's what I called it. Expansion. I got to where I was supposed to get. In grad school, we had these cubbies, kind of like office space where you can put things and hang things up with pins. I used to always put my extracted stuff up there so that I could write my proof and just look up and see all my stuff. So the other direction, I go through the same process. Oh, sorry, it's intersection. And yada, yada, yada for mathematicians is ... So I'm going to fill that in. You do the same thing. So I'm going to show you what the clean proof looks like for this direction, the first direction, so that you see like what a reader would see. They wouldn't see all the other stuff behind it. right, good to go? Clean proof.
So for the opposite side, the only difference would be the expansions.
The expansions would be different, yeah, because you're expanding the intersection, so you'd go X does not belong to A and X does not belong to B.
You're knowing your show, just switch, so you
Yeah.
have to get to your show.
Sometimes, like you see that if it's just an if then statement and only one direction, for some reason, somebody will grab the thing they're supposed to show and then use it in their hypothesis. That's like one of the most common things we see in proofwriting classes. I haven't seen it once we started doing the guides and perfecting the guides, but I used to see it a lot.
You have to start.
You always start with your no and you end with your show. And if there was something in your no that you didn't use at your stage, something went wrong. Because right now they're giving you all the information you need to actually get to the show. By definition of intersection. Right, for the other direction, right? One's a compliment. I mean, it's like if you do this direction. With that, oh, yeah. This correct. What I said was correct,
Okay.
right?
Yeah.
I can, but I should write them the same. They mean the same thing.
Okay, that makes sense. Yeah, I just.
One of the beauties of this class is you get to see how people write proofs and how they think. I always wanted to do a study, like how people write proofs tells you a lot about their personality. I've got a psychotic, chaotic personality. So what I wrote was correct, but it was complete chaos. And I've loved working with different mathematicians over the years. And sometimes I have one paper where there was a person that was just fabulous, trained in Poland, came to the United States, and one of the best mathematicians in my field. And he would do things geometrically. So he just saw things as pictures. And on our side, I was working with an algebraist. So we would use a class, an algebraist. There's actually a whole field of math called algebra, not the algebra you did when you're little, but it's a field of math called algebra. And so we would look at polynomials and minimal polynomials and do things with those polynomials. And I had proofs on that side written all algebraically, and then we had identical proofs written all geometrically. And the guy I wrote with in the algebraic stuff, he was very artistic. So like when he went up to do math at the board, it was like Picasso going to the board. The way he write was so elegant, where the geometer kind of guy was more like, I see this picture in my mind. I need to explain this picture. So he's very visual in how he explained things. And then there was another guy I worked with who was like very prim and proper, came to class, like he had everything organized in class. And how he did math was he started putting bookmarks into books for everything that was relevant. Everything was organized. Like that was his personality. That's how he did his proofs. So I always think like there's some connection between your personality and how you write proofs. It is reflected other places. So we see that in NLP, how people write is you leave behind, we call it personality residue. But long before I did anything NLP, I always thought when I saw mathematicians doing proofs, like, wow, they are exactly, their proof is who they are. Well, sometime in the semester, like I love the boards around here. I always wanted to write one proof all the way around the boards. And I did in a foundations class, and the class said, don't ever do that again. So I'm not going to do that again. But one time I had everybody write a proof that they could write on the boards. And then I had everybody walk around and look at how differently the proof was written, even though everything was correct. It was just the style of the person. So I think it's fascinating. Unfortunately, you can't make general public learn proofs to test this one out. I think Berkeley pumps out 60 PhDs per year in math. We could go to Berkeley and run a little study. But let's look at this clean proof. So you can already see who I am from this. Dr. Clark, who was teaching real analysis last year, he would always say, we want to show. I'm task oriented. I need to show. I'm listing out my tasks. I always let my reader know right at the beginning what I'm trying to do. If you watch Planes, Trains, and Automobiles, when you're telling a story, have a point. It makes it so much more interesting for the listener. So that's why that's there. Tells the reader where I'm going with this. Okay, good. Josh is my metric. And Isaac. That's fine. Good. That's not correct. This is what I meant to say. I claim that. See, I changed my little notations and everything, my shorthand, into words. Cannot belong to A. Or if it did, then X would be an element of A union B. That's how I just shortened up what I just wrote. I have all my notes sitting there with all my scratch, and I just said what I saw in my notes. I claim that X cannot belong to A, for if it did, that was my proof by contradiction earlier, then X would be an element of A union B. This would violate my hypothesis that X cannot be in A union B. For a similar reason, X can't belong to B either. and intersection. Everything I say has a citation attached to it. Like documentation on steroids. I'm going to give you the clean proof of the other direction as well. Just so you can see what it looks like. So it's not gonna have all that scratch work with it. You understand now like how to expand all the scratch work so you can get all your pieces out. So you might be thinking, well, she's making this hard. These proofs are pretty rinky dink. You write out your no, it just kind of falls out. But if you don't adhere to those good principles of doing those things right, when the proofs get harder, which they are, I don't use a book because I don't want to show you bit by bit by bit and go through set theory for 2 months. I'm going straight to actual math. We're going to number theory next. I might do algebra next. I don't know what I'm going to do after that. I make up my mind as I go. But when you get to those complicated things, and that's why I gave you a complicated thing to look at your homework, those sets are complicated. And I see topology fall apart. You know, the one thing they did last homework, I gave them something to prove that wasn't true. How would you find out that it wasn't true? What's step one of proof writing from good practices? Examples. None of them did examples. Not a single one wrote an example. And it wasn't true. And so they have proofs that have flaws in them. They just drove on and, you know, like that. It was a complicated thing. It was a really complicated thing. They should get that, right? They signed up for it. I don't want to make topology easy. It's just not. So you write proofs for complicated things, not for uncomplicated things. Not for things that we can kind of look at and see. So don't like skip these things. It's like, you know, somebody who wants to do around the back and they haven't learned to dribble properly in the first place. Got to dribble properly first and then do all those other things. Learn how to do those things first. So like these good practices are going to be good for you when we get into things like real analysis. Good. All right. Maybe we'll go to, before I go to the other side, just to show you that, because it's like, I've been talking about this for a long time. It's a little bit, but I'm getting bored.